Shall we dive deep then into what catalogs are?
Let's do the deep dive. Okay. So, first off, what is a data catalog, right? I feel like people often conflate data catalogs and table format. So if you go on the Apache Iceberg website,
Hmm.
um, and Apache Iceberg is actually both a catalog and a table format. Okay, so Apache Iceberg itself is an open table format. So first, maybe let's address that. What is a table format, right? Back in the day, you would just have files laying around on disk, and those files would represent one table, right? So if you have like CSV files, maybe like five CSV files, they all share the same schema, and then they will represent one table, and you were kind of good, right? The problem comes when, let's say, you want to like start adding data to the table, and you start adding, new data, and then you have multiple writers that may be adding data, and then you're like, oh, but what if I wanted to also like delete some data, right? And so you have all these like different writers coming in and trying to write and read and delete the data all at the same time. And just the abstraction of just having files on disk no longer suffices because essentially you're almost building like a database. Like you need each reader and writer to be able to know at which point in time it's trying to read that data, right? So for example, if reader A is reading data today, it's like reading this like idea of a snapshot at like this point in time of today, right? Which maybe consists of still like five Parquet files. But if reader B reads it tomorrow, it might be reading a different snapshot in time, which maybe then at that point has 10 Parquet files, right? How do we then keep track of like the different states of these tables? That's the job of a table format. So I was going to show off this example iceberg table. So here's what an iceberg table looks like under the hood, right? On one
Hmm.
hand, we have just like the basic Parquet files, which are just kind of laid out like in on disk. These are all just Parquet files in these folders. This table is partitioned, and that's why you see this like hey, here's all the data relating to like this month in this column, right? But yeah, it's literally just like Parquet files sitting around.
So
Nothing too
catalog,
special about this.
you're kind of a layer of usefulness on top of Parquet files that let you do things um like snapshotting, schema evolution, things like that.
Correct.
Like,
Correct. So it's this is the job of a table format. That's not the job of the catalog,
I
to be
see.
clear. So the table format itself is almost fully contained in this folder because like you have the data itself, all these Parquet files, right? But in addition to that, you also have metadata. And
I see.
Iceberg represents that metadata as JSON and Avro files.
Mhm.
And so I'm not sure. I think it might not be as helpful to like open one of the JSON files. It might be a little too confusing. But you can think of these JSON files as like telling you, giving you metadata about, hey, at this point in time, here's all the data for the Iceberg table, right? In like commit yesterday, you added 10 files. Here are the paths to those 10 files. And commit today, we added an additional 50 files. Here are all the paths to those 50 files. And so in order to understand like, hey, for a given query of this table at this point in time, what are all the files I need to read? What you can do is that you can just read this metadata, basically look at the metadata, see, okay, which files were added, deleted, and like, what happened in that timeline and reconstruct that set of total data you need to read. And then you can go and read the data down here. And that's how you would read a table format.
I see. So this is open table format.
Yes, so Iceberg, Delta Lake, and Hudi are all open table formats. They pretty much all use these open data standards like JSON and Avro and Parquet.
Mhm.
Parquet usually the industry has basically centered around Parquet as like the data representation. So data itself is usually represented as Parquet like this, right? But the metadata is oftentimes represented as something like JSON or Avro, which is a lot easier to read than Parquet and faster and actually just a human readable. So if you open one of these JSON files, yeah, you'll just see that like so this JSON file tells us that hey, this is the location of the table, right? In general, um, this is the current schema of the table, right? It has all these
Mhm.
columns,
Yeah.
and yeah, this is the current snapshot ID. I think this was the very first snapshot, and it
Mhm.
also tells us a partitioning spec. Yeah, that's the general idea of table formats. They're not all that complicated, right? It's just like files lying around, and then some metadata describing at particular points in time what is the shape of those files, the schema, and also what files you should be reading in order to understand what the table is at particular points in time on the timeline of like the life
Mhm.
of that table.
Wow. So it's like Git for data.
It's like Git for data. Exactly. Yeah, that's a great way to put it. It's Git for data.
I'm curious, like how like what's the scale it can support? Like, what if
Yeah.
how many schema evolutions can you do?
Those schema evolutions are pretty scalable, right? All you're doing is kind of just like changing the schema
Yeah.
of the file. So there are certain allowed operations on the schema you can do, for example, that are non-destructive. For
Yeah.
example, it's completely fine to add a new field, right, or
Yeah.
a new column. That's completely non-destructive. Um, what you can't do, for example, is like let me think of a good example. So like deleting a column is fine too, because what you would do then is you would just ignore that column whenever you read the files.
Mhm.
Um, Renaming a column is also fine. There's like
Mhm.
ways around it with Iceberg. But there are certain like destructive operations that just based on schema evolution, you just like the iceberg will tell you, hey, you're not allowed to modify the schema this way for this table. So that's pretty scalable. These table formats were built to hold pointers to like millions of files. And that's because they're all contained within this metadata object. And so one problem too with having just like flat files, like let's imagine you didn't have all this metadata, right? You didn't have a table format, and all you had was this data. In order to get all the files, you have to list across the entire bucket, which is actually incredibly expensive if you have a ton of files, right? Imagine you have some automated process of like bringing files in, it gets super expensive and you get a ton of files here. But the table format, because it's organized around these metadata files, can give you just a few metadata files from which then you can derive the entire span of your table, like all the different files, and all those file paths are just contained in these like Avril and JSON files, which is very, very cheap to read, rather than running a full listing, which might take minutes on larger tables. So yeah, that's kind of it for table formats as an introduction. And so the main table formats out there are again Iceberg, Delta Lake, and Hudi. And yeah, Daft currently supports reading from all of them, which is really cool. And I think we need to then maybe talk about data catalogs. What is a catalog then? If this is a table format, right? So table formats are exactly what we saw just now. This kind of like layout of data on a file system almost, or like object store, right? Where it's like data and metadata. That's a table format. A catalog, it's a little bit different. It's this idea of being able to tell you where these tables are. So a catalog is a higher level abstraction. It's almost you're able to then access like, hey, for like catalog with name A, right? I want like table name foo, and the catalog will tell you where that table is. And the catalog will also provide you with metadata about the table, such as like schema, right? And it can give you like a bunch of metadata too, deriving from the table format, like minimum, maximum statistics and stuff like that. But generally, a catalog manages tables and tables manage files. That's the kind of the hierarchy I would think of it as, right? I think the reason why people often complete the two and like use the two interchangeably is because projects like Apache Iceberg actually ship their own catalogs. So the Apache Iceberg catalogs, for example, are these services you can deploy that then tell you how to access different Apache Iceberg tables, right? So for example, let's see if they have it in the quick start. Catalog. Yeah, so in this example, this is the Spark catalog. Let's see if they have concepts catalog here. So you can think of Iceberg as a format for managing data in a single table. That's a table format, right? But then the Iceberg library itself needs a way to keep track of these tables by name. So if you want to like create, drop, and rename tables, right? That's the responsibility of a catalog. And currently, Iceberg itself supports a couple of catalog implementations. And so there's like the REST catalog, which is a service you deploy. There's one you can deploy on the Hive metastore, which is usually like a SQL database. You can deploy it on JDBC, right? Any JDBC compliant database can do this for you. There's Nessie. There's also this AWS Glue, which is something that we use sometimes. So if you go to AWS Glue, this is the catalog on AWS. And so if you are a current customer of AWS, you can kind of go to the data catalog section, and then it'll show you, hey, here are all the different databases you have, and within each database, here are all the different tables you have, right? And these tables are, in fact, Iceberg, exactly. So if I click on this, it's going to tell me it's an Iceberg table, right? Table format, Iceberg. What's cool about things like Glue is that they are table format. They support multiple table formats. So Glue actually supports Iceberg tables, also supports Hive tables, Delta Lake tables. But yeah, that goes to show that like really the data catalog is a separate abstraction on top of a table that isn't tied to a specific table format. But the reason why people often talk about them interchangeably is because people often just like go, okay, I want to use Iceberg, and therefore I need one of the Iceberg catalogs. And so they just kind of use interchangeably, and they go like, okay, I have Iceberg data catalog, and I also have Iceberg table formats.
Yeah, you can't. I guess it really makes sense, for like enterprises. Like if you're using like Apache Iceberg table format, you probably should use the catalog as well.
Yes, if you're running your own self-hosted thing, most people I think just run the REST catalog themselves. There's also and if you're on some sort of vendor, right? If you're on Databricks, then you're using the Databricks Unity catalog, which under the hood just is all backed by the Delta Lake table format. If you are, in AWS, then yeah, you'll be looking at something like Glue as your catalog implementation. If you were running your own thing entirely, then yeah, you would probably be deploying your own catalog, something like a Apache Iceberg REST catalog. Yep. Okay, so I feel like we've got all the terminology kind of like all squared out, which is good. But now we can, I guess, talk about like our current level of support, right? So Daft currently supports reading table formats really well, right? And what I mean by that is that you can point Daft to an existing table, such as, in the case of Delta Lake, you can point Daft to read Delta Lake, here's the path to the Delta Lake table, right? So it could be local on your machine in this case, or it could be an S3, give it an S3 path, and it's going to go to that S3 bucket, that path, and it will look for a Delta Lake table. Similarly, in Apache Iceberg, when you do daft.read iceberg, what we do is we allow you to create this table object from the PyIceberg client. And so you do from PyIceberg catalog and load catalog, you create a iceberg table object, and then you pass it into Daft. Right? You do like df daft.read iceberg. Here's the table I want you to read. So Daft is really good at reading tables right now. And we also do support already all these pushdowns. So for example, if after reading this iceberg table, you do like, I want to filter, right, this partition key less than 1000, and then I'm going to execute my query on the iceberg table, Daft will efficiently make use of all the metadata available, right? So for example, Daft will go, okay, I'm going to look at the metadata in this table, right? And I'm going to see, first of all, like, is this partitioning key in this partitioning spec, right, of the table? If it is, then I'm going to do the pruning just based on the partitioning spec. And so Iceberg, for example, will allow you to just like completely ignore certain files because it knows that those files don't correspond to the partition key. So Daft is able to do this, what we call partition pruning, using Iceberg and kind of leverage all the power of Iceberg there. And so Daft is really, really good at like reading table formats, right? I think where like it's going to be very interesting for Daft to start supporting is how do we start, interacting with catalogs rather than tables. So if you notice in this case, it's all about like reading tables, right? We don't yet have a Daft catalog abstraction, which a lot of these other query engines do. So Spark, for example, Spark has a catalog abstraction, which allows you to say, hey, here's the catalog I want, right? AWS Glue, or here's the Iceberg REST catalog. And then once you have that, I really like this API from Spark, which is you would just do like, you would do spark.read.table, and then you would give it a table name. And oftentimes this would be more of a like full identifier of like catalog name dot database name dot table name. And so when you pass this into Spark, it's going to be able to like figure out, okay, like I'm going to be using this catalog, right? I'm going to be hitting this database, which is like a sub hierarchy thing under the catalog, and I'm going to be hitting this table, which is another sub hierarchy thing under the database. So we already have this right now in Daft, but I think it could be really cool, and I think we also do have an issue out for it. Data catalogs, yeah. So this one I think Clark made, which is really cool. You can just do like daft.read catalog table, right? And you give it the catalog ID, database name, and table name, and like bam, like you don't even have to tell us it's an Iceberg table. You don't even have to tell us it's a Delta Lake table. Like we figure all that out, right? And automatically, like it becomes a data frame, which I think it could be really cool. Yeah. So I'm really, really looking forward to this. I think we just need to like flesh out all the APIs needed to make this possible, because this will take I think a little bit of effort in like supporting all the different data catalogs. This just so many of them, and some of them are proprietary, like Databricks, for example. We have to probably test on the Databricks platform. But once we have this, then it's I think in terms of usability for our users, right? We can do things like set a default catalog. So at the top of your script, we can set a default catalog, or we can maybe detect it from the environment. Hey, like someone's in some YAML config somewhere. Oh, it's a default catalog. And then when you do database name dot table name, it just picks it up. And we can also provide APIs for like default catalog dot list tables, right? Show me the schema of those tables. Now that all those operations I think become very, very easy then to just using Daft as an interface to your data catalog, which I think is very powerful and allows Daft to be a lot more useful for ETL tasks. So yeah, I think some of the really interesting things coming to Daft would be this kind of catalog support, right? Where we're able to just set a default catalog, let's say, where you can do like Daft, set default catalog at some point, either we detect it from your environment, or we're also able to like set it at the top of your script. And then when you do like Daft read catalog table, we're going to be able to just pick up which catalog you're trying to hit and just find the table and also understand what table format it is, and be able to read that natively into Daft. Yeah, and now we can maybe talk a little bit for the last couple of minutes, talk a little bit about our scan operator. So how does this all work under the hood in Daft? So if you look at the implementation of Iceberg, Delta Lake, and Hudi, so you'll see that there's just one folder each: Hudi, Iceberg, and then Delta Lake, right? And all of them look extremely similar. All that we do is we create what's called a scan operator. I think we talked about this a little bit before in this meeting. But we subclass the scan operator, and we just need to go from this pushdowns to scan tasks. So let me go into that a little bit, right? Pushdowns are things that Daft is trying to push into the scan, right? So these are things like Daft will tell you, I want to apply a limit to the scan. I only need 100 rows, right? Or Daft will tell you, I want to filter the scan. I want to, not scan any rows that meet a certain criteria. And now that the scan operator receives this pushdown, it can then apply table format specific logic to accommodate the pushdowns, right? To apply the pushdown. So for example, in Iceberg, it will look at the pushdowns and say, hey, is there anything I can do here with regards to like partition keys that I can then remove any unnecessary scanning that I need to do. And so the result of this is after applying the pushdowns, your scan operator just needs to return an iterator of scan tasks. And scan tasks are pretty simple. They look like this. You have the path to a file, and then you have the file format. In most cases, Parquet. You have the file schema, right? And then a whole bunch of other metadata, including the pushdowns you want to apply on the file and the size of that file. But once we provide this to Daft, then Daft actually just takes care of the rest of it, right? Daft will take this iterator of scan tasks and start materializing these scan tasks as necessary. But what's the crucial bit here is that this scan operator is in complete control around what scan tasks it wants to return, and Daft just like kind of queries it and provides it with information about what it wants to read using this pushdowns object. And using this mechanism that is so simple to implement anything for a new data catalog, everything is usually under 200 lines because most of the logic is just in this toScanTasks method. And so supporting something like Hive, for example, is very simple. And then if anyone has their own kind of proprietary table formats, this is going to be a very simple way to integrate with Daft.
Yeah, it's really neat. The scan operators, all it does, when you call toScanTasks, it does all the pushdowns for you. And then the scan task itself is all it does is just give the task to our native Parquet readers, for example, which we already implemented natively in Rust, which makes it really fast.
Yep. And I guess like this is like such a general way of reading data into Daft, right? Because if you look at again the SQL implementation of the scan operator, which I thought was super cool. It's the same concept. It produces scan tasks, but these scan tasks that it produces are a little bit different. I think they're not like the general the same ones that Iceberg and Delta and stuff all use. We have a special scan task called a SQL scan task, right? Where instead of providing it with a file path, we provide it with a URL to the database. And so the scan task, it's like if you try to materialize the data in a scan task, it's going to hit the database to grab data instead of reading a file. And this is how we can kind of instruct Daft to scan data when reading into a data frame.
Yeah, and with pushdowns as well, even for the SQL scans.
Yes, very cool. Yeah, with this pushdowns object. Yeah, that's all we have for today.